Hello everyone, in this video I'm going to explain the working of bit shift left, that is the BSL instruction for shift register in PLC programming using an automated ice cream machine example. BSL instruction is used to move the bits in a shift register to the left side one by one. This operation comes into play whenever we provide a clock signal. So let's see an example. I'm having an automated ice cream machine. A sensor S1 checks whether the cone is broken or not. I'm having three machines M1, M2 and M3 to add ice cream, sprinkles and peanuts to the cone respectively. If the cone is broken, all three machines should not work for that particular cone. Let's take a look at the ladder diagram to see how the logic works with the PLC. I'm having a switch labeled new cone, that is whenever a new cone arrives the machine, this switch gets enabled. Next I do have a BSL instruction. For the file I have given the address of shift register, which is hash b3:0. The control is rs:0. The bit address, I am providing the address of the cone sensor. So the sensor gives a 0 for a broken cone and 1 for a perfect cone. When we provide a clock signal or when a new cone arrives, the cone sensor gives the appropriate signal to the shift register, and as new cones keeps on arriving, the BSL operation moves this signal or the bits to the adjacent one on the left side. I have chosen the length as 3 since we are having 3 different machines, so we just want to use the first 3 bits of the shift register. On the next 3 rungs I am having 3 inputs which corresponds to 3 bits of the shift register. Bit 1 is having the address B3 colon 0/0. Bit 2 is having or the input 2 is having the address B3 colon 0/1, and input 3 is having the address B3 colon 0/2. Also I do have 3 outputs which corresponds to 3 different machines. Output 1 is for ice cream, output 2 is for sprinkles, and output 3 is for peanuts. So whenever the input bits get enabled, which means there is a perfect cone available under that particular machine, the corresponding machine works. Now let's take a look at the data files. This is a data file for the shift register, and this is the data for the input and the control. Now let's see how the program actually works. Here I have given the I colon C1 I colon 1.0 as the cone sensor. So in order to provide a perfect cone, that is an unbroken cone, I can give this as a 1. So when I toggle the new cone or new cone bit, or I provide a clock signal, as you can see the first machine is enabled because that's actually a perfect cone. So the first bit is enabled, which in turn enables the output 1, that is a first machine which adds ice cream to the cone. As you can see here, the first bit of the shift register, that is the LSB, gets 1. So in order to provide a broken cone, I can toggle this bit to 0, and the next time when I provide a clock signal, that is the next cone arrives, the LSB becomes 0 on the shift register, and you can see the first cone moves to the second machine and the second machine gets enabled, and the first machine is having a broken cone, so the first machine is not working, or the ice cream is not added to the cone. And next one, I can provide a perfect cone. I can toggle this bit and provide a new clock signal, and as you see here, the first machine gets enabled, the second machine is turned off, and the third machine where the perfect cone is placed, it turns on. And I can keep on doing this. And now you see here, when the 3 bits are passed or 3 counts are passed, there's the MSB on the shift register is moved to the UL, that is the UL bit of the control. So that's the working of shift register using an example. I hope it's clear. Thank you for watching.